Good morning and happy Tuesday. Today we're going to be finishing the notes on solving systems by substitution. So remember, there's more than one way to solve a system of equations. We already talked about graphing. Yesterday we talked about substitution, the substitution method, and that's what we'll be finishing up today. The couple steps on how to use the substitution method. The first one is we're solving one of the equations for one of the variables. It doesn't matter which variable, it doesn't matter which equation, whichever one looks easier, solve for either x or for y. Sometimes though, they are even given to you, x will be solved for or y will be solved for. Second, you want to substitute whatever you solved for, either x or y. You're going to substitute that into the other equation, okay? And you're going to solve for the remaining variable. Okay, once you get your x or your y, you plug it into the other equation, and that will give you now both of the x and y values, and you're going to write your solution as an ordered pair. And the last part is you can always check your solution by plugging each x and y value into each equation to see if you get the right answer. So yesterday we did just that. We solved some systems by substitution. We talked about what an inconsistent system is. So if you are solving and you end up with something such as 12 equals 0, which is not true, that means the lines are parallel and you will never have a solution. So you would say that there is no solution. So that's what happened in this example 3 and example 4. Today we are looking at some word problems. So we're going to go through the last 2 problems together, and then you guys are going to complete 3 problems on your own as an assignment that's also posted in Google Classroom. So let's read this together. It says the cost of a ticket to the circus is $25 for children and $50 for adults. On a certain day, attendance is 2,000 and the total gate revenue is $70,000. So revenue is how much money the circus made. That's how much money they brought in. How many children and adults bought tickets? Write a system of equations and solve by substitution. So the first thing we have to do, we know we're going to have x, we know we're going to have y. We have to define our variables. So we'll say let x equal, let me zoom in a little bit. So we'll say let x equal number of kid tickets. And we'll say let y equal number, and remember this is number, not hashtag, of adult tickets. Okay, so the first thing that we know is that the attendance is 2,000. 2,000 people attended the circus. So the number of kid tickets plus the number of adult tickets, that's how many tickets altogether there were, and we know that's 2,000. So our first equation is going to be kid tickets, which is x, plus adult tickets, which is y, and that's 2,000. Then we know it's $25 for children, $50 for adults, and the total amount that the circus made was $70,000. So the second equation, well, if we want to figure out how much money was made just for the kids' tickets, well, it's $25 for each kid ticket, so 25 times x. So you're going to take 25, that's how much one kid ticket cost, multiply by the number of kid tickets. Then you're going to add, same kind of concept, $50 for each adult ticket, multiplied by how many adult tickets were actually bought. And we're going to set that equal to 70,000. Okay. Again, x plus y equals 2,000 is how many people attended. Kid tickets plus adult tickets totaled 2,000 tickets in all. And then we have $25 per each kid ticket. So x represents the number of kid tickets. And we're adding $50 per adult ticket. So 50 times y represents adults, is equal to 70,000. Now that we have our system of equations, the first step that we want to do is solve for either x or for y. So I'm going to take x plus y equals 2,000 because this one looks a lot easier to solve for either x or y than the other one. And I'm going to solve for y. Again, it doesn't matter which one you solve for, but I'm going to subtract x from each side. That gets rid of my x's, and I have y equals 2,000 minus x. Or you can write it negative x plus 2,000, either way. Okay? But we solved for y. Okay, now the second step is to substitute. So we remember, when we solved for y in our first equation. Now when we substitute, we must substitute this into our second equation. Okay, so I have 25x plus 50y equals 70,000. I'm going to substitute into here. So it's going to be 75x plus 50 times y, but instead of y, we're going to put it in terms of x, which is 2,000 minus x, and that equals 70,000. Our next step here is to distribute. So I have 25x. I got some big numbers here. I have 50 times 2,000, which gets me 100,000. So plus 100,000. It's a lot of zeros. And then 50 times negative x gives me negative 50x. That's equal to 70,000. Okay, now I want to combine the like terms. So 25x and negative 50x. Well, 25 minus 50 gives me negative 25x plus 100,000 equals 70,000. Now I have that two-step equation. I'm going to start by subtracting 100,000 from each side. And I'm left with negative 25x equals negative 30,000. And last, I'm going to divide both sides by negative 25, which gives me x equals 1,200. So far that means we have 1,200. X represents kid tickets, right? You have 1,200 kids. Now we have to figure out, well, how many adults came? So my third step here is to take this, x is 1,200, and I'm going to plug it into either equation here. It doesn't matter. Again, use the easier one. That's what I'm going to do. So I'm going to use x plus y equals 2,000. So I'm going to replace x with 1,200 plus y equals 2,000. My final step here is going to be subtract 1,200 from each side. And I'll get y is equal to 800. So there we go. I have 1,200 kids, and y, if we go back up to the top, we know that y is adult tickets. So we have 1,200 kids and 800 adults. Okay, that is our final answer here. Please make sure you've copied all of this down either on a piece of paper or on your copy of the Jamboard. But again, there's a lot of steps here, so you do want to make sure you are copying this down. That's how you're going to remember it. And we're going to do one more word problem together. So it says the Science Museum charges $14 for adult admission and $11 for each child. The total bill for 68 people from a school trip was $784. How many children went to the museum? write a system of equations and solve by substitution. This one is very, very similar to the last one, right? We know how many total people went, and we know the total amount that was spent on the school trip. So we do have to define our variables. So we'll say let x equal the adults. We'll let y equal the child. Okay. So the first thing we're going to do, well, we know there was a total of 68 people that were there. So the number of adults plus the number of children totaled 68. That's our first equation in our system. Then we also know that it was $14 for an adult, $11 for a child, and the total was $7.84. So for adults, it's $14. So $14 times the amount of adults. We're going to add $11. Doesn't really look like an 11. Let me erase that. So $11 times however many children went. And when you add that up, you will get a total spent of $784. Now that we have our system of equations, the first thing we're going to do is we're going to solve for either x or for y. Let's solve for y. Okay, and again, this one's probably going to be the easier one to solve for. So I have x plus y equals 68. And I subtract x. I get y by itself, and I have 68 minus x. After I do that, the second thing I'm going to do is I'm going to substitute this y equals 68x into the other equation. So I'm just going to write this here, 14x plus 11y equals 784. So I'm going to replace y with 68 minus x. So I'm going to have 14x plus 11 times, I take out y, I put in 68 minus x, and that equals 784. So here, now I have to distribute. 14x will stay the same. 11 times 68 gives me 748. And then I have 11 times negative x, which gives me negative 11x. And that's equal to 784. So from here, I want to combine my like terms. 14x and negative 11x. So 14 minus 11 gives me 3. So I have 3x plus 748 equals 784. Now my two-step equation, I'm going to, subtract 7. Oh my gosh, I can't write this. 748 from both sides. And I'm left with 3x equals 36. And my final step is divide by 3. So I have x equals 12. So far, I know we have 12 adults. We have to figure out how many kids there were. Okay, so we're going to take this, x equals 12, and we're going to plug it back into one of our equations. That's going to be our third and final step here. So again, I always use the easier one, and the first one, x plus y equals 68, is easier. So for x, I'm going to replace with 12. This way I can solve for y now. So I'm just going to subtract 12 from each side. And I'm left with y equals 56. So that means there were 56 kids. So on this trip, we had 12 adults and 56 kids. Okay, so it's very important you copy all of this down so you have it somewhere to look back on. Remember how I said every Regents exam always has a system of equations where you have to write them and then solve them. Okay. So this is the end of solving systems by substitution notes. So you will see in our Google Classroom, let me go back to it. You will see this is posted, Tuesday practice systems by substitution. So when you click on it, you'll come here. So you're going to complete this assignment by using substitution. Again, you're using substitution. So you have 3 questions. Okay, you're going to solve 1, 2, and the last one is a word problem. So this is like what we just did today in this video. So if you have any questions, please feel free to reach out to me. I will do my best to get back to you as soon as possible. If you would like me to check your work before you hand it in, as always, email me. I'll check it, give you some feedback, and then you can fix or either hand in from there. Okay, so hope you guys enjoy the rest of your day, and I'll see you guys tomorrow.